Well, I have been there's been a lot of coverage. I don't know in what I look at about hardened images, registries, repositories, catalogs, taking track of your keeping track of your VM, securing things. You got it. You got skiffs here. You got bunkers over there, and then you got people over here who are just like, let's just have an AI execute whatever arbitrary code you want. And so I thought Tony, you should have William on here. We can talk about some of these topics, maybe all of them in a speculative fashion. So that as always, maybe this can be an episode, Tony, called "Educate Cote." I think maybe we have a sub series here in the Tanzu Catsup, which I think would be great.
No, I'm looking forward to this one. I'm really glad we have someone on because this is definitely not in my wheelhouse. And William, just so you know, I may be interjecting here and there with some what I would consider customer angled questions. So hopefully we don't catch you too off guard.
Well, why don't you tell us who you are, William?
Yeah, sounds good. Hey, great to be here and looking forward to talking about security. I'm the product manager at Broadcom for a product called Bitnami Secure Images. So that's all about hardening the open source supply chain that so many developers around the world depend on. And I'm based in California and talking to you from HQ today, actually.
Yeah, I recognize it's nice back there. Every time I see that background, I think, oh, man, the lunch selection there is fantastic. I need to get over there and get some with the whole. Is there still like a whole dedicated? You've got like It's kind of like Epcot Center in there. You've got multiple like nationalities and countries, and then isn't there like a dedicated Indian food place just 24/7?
There's a pizza bar. They have if you want a hamburger, you can always get that. It's very reliable.
Constant hamburger. Well, totally unrelated to hamburgers, unless we can somehow force it between two delicious piece of bread somehow. Like I wanted to start off with I just rattled off half comically a bunch of phrases there, but I thought one good thing to start with would be when it comes to you know I'll use the word images broadly here, but what is an unhardened image? Like whenever I hear a word, the first question I have is like, what's not that? In order to get to the definition of it. So what would be a soft image? I don't know.
Yeah, it's a great question. Do we just make up this term, or was there really unhardened images before? So I think we got to take a step back and probably look at what a container image is typically. And so to container image contains software, but the foundational layer of that image is you need an operating system like layer. It's not really an operating system, doesn't have a kernel, but it's got all the bits that make that look like an operating system that a software would depend on. Typically, these layers that people use, these foundation layers, use a general purpose operating system, something like Debian or an Ubuntu or a Red Hat Linux. Now, these are operating systems as they were designed for the 1980s, the way we ran servers in the 1980s. You needed an interactive login system, user management, text editors, even had a mail client, which was kind of fun. It told you got mail when you logged in, kind of cool stuff. I don't know, I liked that. That was kind of the highlight of my day sometimes.
It sounds like you might be pining for those old days.
There was something cathartic about logging into your Unix servers every day and just kind of seeing what's up and checking your cron jobs, and it had a routine to it. There was a meditative aspect I admit.
Indeed.
So anyways, all that stuff's great if you're running a pizza box server in a data center 20 years ago, but if you're running a container, you don't need all that stuff, right? You just need the container is just the environment to contain a specific piece of software, usually a single function software. And so you really want more like a lights out environment. Lights out is like a data center term, meaning there's no lights in there because humans aren't going to be in the room. So the container should be the same way. It should just have only the software needed to run that piece. Only the dependencies needed to run that software. So that's what a hardened image is. That's one aspect of a hardened image, is removing all the stuff that's not needed because a human shouldn't really be messing around in there. And then the next thing we can do with a hardened image too is we can also make sure that we're using maybe security libraries that are more appropriate and more meet a certain threshold of cryptography. So things like Federal Information Processing Standard, FIPS, that mandates that we use ciphers that can't be easily broken. Sometimes a library inside a container image has a lot of different options for ciphers, and you could actually choose something that's not secure enough. And a FIPS cipher module in that container image makes sure that there's a minimum bar that is not easy for someone to brute force crack.
So far we've removed stuff like, you used to have the big bundle of everything that you wanted, checking your mail, maybe running finger or whatever to see who's in the lab across the street, and then it seems like the other thing that you do with hardening is you're making sure you know what's on there, like which often when it comes to compliance and audit stuff is just like, I mean, tell me if I'm simplifying it too much, but a lot of compliance stuff to me seems like, one, establish that I trust what you're saying. Once I trust what you're saying and that you're actually going to do it, two, here's what you're going to put on there and here's what you're going to do. Like this version of the software is approved for you to use.
Yeah, exactly. And then you can back that up with like source bill of materials to enumerate all those things that you put on there. So there's a declaration of these are the specific things that we chose to put on there. Yeah, so it's kind of a higher degree of authenticity that way.
Hey, William. So I hear customers a lot. They bring up, I'll hear them in meetings with them. Are we using, a hardened image? Is there like an industry standard around what that means? Or I would assume that every customer has like some definition of what the hardened image is for their company. Is that true? Or is there like a golden hardened image kind of standard somewhere?
Yeah, I mean, I think the answer is there's probably multiple. There are things like this, the CIS benchmark for various Linux operating systems that tries to set a standard for what a secure operating system is. There's also the federal government has something called STIGs, and STIGs are very specific documentation and policy that's been written for a particular application or operating system for how it needs to be run to be hardened. And that gets into the realm of, for instance, things like, turning off a port that is open by default, or making sure a user permission is not automatically granted, minimal password controls, disabling maybe a feature that makes it easy to use something but less secure. So those things exist, but there's many standards. So back to the whole question of, is there a standard? Yes, there's multiple standards. So there's that problem. Maybe a more like objective measure could be CVE count. It's kind of a hand wavy way to approximate hardenedness, but it is common. It is a common way to measure this, is to say, well, how many CVEs are in the image? And so a lot of vendors are trying to get to near zero CVEs, and that's considered a rough approximation of hardenedness because it kind of shows the level of liability in the image.
Near zero, Cote. As close to no CVEs as we're willing to bet on.
Yeah. No, that make and I mean, I don't know, to maybe dig into the hard hole too much. Like, is it all driven by CVE reduction, or is there always like best practices? Like you're saying, removing the email client, like that seems obvious, but is that something different than hardening? Is that just saning, or like I don't how's that fit in there?
Yeah, no, I think that's hardening, removing those things that shouldn't be there and setting sane best practices that are more defensive, like don't have the default password, admin, make that
Right.
like your router password. That shouldn't be the thing you ship the product with.
Right.
Um, uh, and then the CVE measure, I think it's a poor substitute for measuring hardenedness, but I mention it because it's a common one because it's so easy to put a metric behind
Right.
it.
It might be like the only, or only is a strong word. It might be the best measurable way of like rating it, right? Like it's definitive versus like I've followed the best practices. Like, right. That makes sense. Okay.
And it's fast because it's a number, so you can say like, what's the number?
Yeah. Okay. So Tony, this is when you were when you talk with, or when you were like running platforms, like how did this fit into schemes? Like where would you get your hardened images, or like Did you harden them yourselves? How does that fit into the platform teams you talk with?
Yeah, like that's why I brought it up. I mean, I think when I was doing this several years ago, we sort of took the ownership of, we didn't call it hardening, but we would sort of say it was an approved image. Like this was an image that teams were approved to use.
Mm.
And that usually meant, security had to do some stuff, scanning tools had to do some things had to be remediated. But most importantly, they had to be in this repository that had access controls and like the CI/CD tools only had access to and stuff like that. So I think the big rules there were around access controls, having some sort of attestation to what's in there, and then having checks around that it hasn't been modified. I mean, that's the extent of sort of like, I think when we were doing this, and that's why I was bringing that question up, William, is because I was thinking, I imagine a lot of customers would see this as something that they would have to do themselves with some sort of process. But maybe that's not true. Maybe there is a way to outsource more of that or to subscribe to something, as an example.
Well, yeah, that happens to be one of the goals of the product that I work on, is to basically alleviate most DevOps teams from needing to do all that work in-house themselves. Because the reality is, for a lot of customers, a lot of companies out there, they need the same set of common container images and the same set of third-party open source. And so we've built a catalog of the most popular open source software that's in consumption, and we have over 280 different applications, so it's pretty wide breadth. But even within that, there's actually like a huge concentration of, it's the top, handful of applications that companies really need. So it's very clear just looking at from our data that there's a common set of open source tools that everybody needs. So it's really easy to alleviate all of those customers' needs because they're all trying to build the same widget essentially.
And so it seems like when one hears the word hardened, you can just substitute built to be secure, essentially, right? And
Agreed.
and that also implies, as you were saying, and I think this part's important. Like there's various certifications or ways of hardening that you can say you have and also have for each of these images as well.
Exactly. Yeah. There's multiple standards, like Center for Information Security (CIS), and then I mentioned STIG, which is part of DISA, part of the U.S. Department of Defense. There's European standards like INSA. There's others. That's just off the top of my head, but many standards. So, but they do start to coalesce. So a lot of times a well-hardened image will check the box for multiple of these standards. So you start to get a commonality.
And then so like, how does the team do that? Like, do they come in on Monday and they have like, they print out a big PDF with a checkbox, and they just go through and they've like, I typed in RM mail client next. Like how, like what does that work look like for the, how many did you say it was? Like all the, I imagine it's the various images and therefore projects that you have, but also multiple versions of them that running on different types of processors or architectures, right? So it seems like a lot of work.
Yeah, it can be. It can be quite tedious. That's one of the reasons we have a team of dedicated engineers who just do this, 24/7, to maintain our catalog that many large companies are using today, to not have to do that work themselves. So for those companies that use our catalog, they just wake up and then they have this OCI registry with a bunch of populated hardened images that have already been reviewed against some of those standards. So for instance, STIG, we produce a STIG report that shows how we've complied with all of those. You must disable the mail client and turn off insecure ports actions. We show a report that we've done all that. And then we also have a scanning reports that show the number of CVEs, and an antivirus report that shows if there's any, that's passed all the antivirus checks. And then a bill of materials that shows, we don't have that many packages. We've removed all the unessential ones. And then there's also an attestation side of this where we have cryptographic signatures on that image, as well as a proof of provenance chain of where we got all of the dependencies from that we put in the image. So kind of like in a supply chain, you want to know you made it, if I baked bread or something at a factory and I have flour and yeast and water. I also want to be able to show where I got the flour and the yeast from and make sure that I got it from a authentic source, because that's a dependency in the ingredient in the package that I'm creating. And so we can show those secondary and tertiary dependencies as well in our SALSA compliant manifest. So you get this big, basically, report showing everything that's in there, where we got our sources from, and then it's signed with our signature to prove that, so that the receiver can prove that it hasn't been tampered with when they receive it.
And then like per I don't know, standard, whatever it's called, is like does a lot of that come from like an external source, like run this script to verify this thing, or does the team have to basically go from a written standard to everything else, like to coming up with the harness where you would like, let's scan this stuff and make sure all the ports are closed, knowing all the various configuration files that all the different, I don't know, applications on this image uses? Like what does that harness across the various things, or is it different for each one?
It depends on the dimension. So CVEs, we can use a tool like Trivy, and we can scan and get a automated result of how well we've done to remove CVEs. Antivirus, the same type of thing. But then some of those more, I guess you'd say, like configuration-based hardening steps, those things, they take a human to review and carefully look at, so they're more tedious. And that's where the report comes in that shows how we've complied is important, because there's a human that's had to answer, yeah, we did this thing to meet that security control.
Right. So like you're saying, there's a combination of like scanning and just trusting the humans that they did something, and then also, like you're saying, like signing the end result, so you've got the thing that was trust, that you said that you should trust.
Exactly. I think it comes down to qualitative and quantitative metrics. The quantitative one is the CV count. We all love quantitative. Easy, it's a number. The computer can spit out a 0 result or a non-zero result. And then the qualitative one is the more tedious one, that the human has to look at the spreadsheet. And so that is where I think for companies that are trusting third parties to provide these, you are trusting the expertise of the team. And so the expertise and the track record of that team is really important. So our team doing this for Tanzu and for Bitnami Secure Images, they've been doing this for 18 years, and so that's something I think is important when it comes to trust and confidence in the security outcomes that the people know how to properly harden these images.
And then how do you demonstrate and like keep that trust? Like there's no scanning for that.
That's what I was just about to ask. Yeah.
Yeah. Well, I think that is through so for one, GitHub is a great way to do this. So we've been building images and Helm charts on GitHub for many years. And so the entire community and internet can inspect and open tickets against it and report bugs when they find them. And so the accumulation of fixed bugs and the continual adoption then after we fix those bugs of said software artifact, I think is one of the strongest votes of confidence. Because you can't manufacture that in a lab. You can't reproduce that quickly. There's nothing like, I think like there's Joel Spolsky has this great talk about rewriting software. Like there's nothing like old software that's got a ton of patches in it, because that test of time and all the humans fixing stuff makes software that is higher quality than anything you could rewrite from scratch. Because when you rewrite from scratch, of course, you introduce bugs you didn't know about. So it's kind of that same, it's got that like, I don't know what the word is, that
it's got a good legacy. It's been road tested, accumulation of things.
Exactly.
Yeah. And it's, I mean, to repeat back I don't know, tell me if you think that this is good, William and Tony, but like you have a track record, of course, right? But then what that means is people can look and see when there have been issues to address, right? When there's something new found that you need to follow through this process. I guess what you want to monitor over time is that, one, not only that it gets done, but there's kind of a constant, what's the word? response time. Like there's a good response time to it. Like there's not a bunch of open issues from 5 years ago. And like whenever something new comes about, you can see that it gets closed in a reasonable amount of time.
Yeah, exactly. And I think we've proven that, and there's a nice log in GitHub of, you know, how long the bugs were open, so you can see that. And then also it's just pressure tested because you've had a lot of people, you know, poking at it and trying to find flaws. And so I think those are things that raise the confidence. And then I think the other thing too is the customers that have chosen to use our software. Um, we have customers that are in extremely demanding environments, like you know, U.S. federal government, you know, classified, unclassified networks, air gap networks, that have chosen to use the software. And to me, that's one of the more encouraging votes of confidence that we've earned. You know, mission-oriented environments like that, we've earned their trust because in those situations, they can't compromise security. They don't take you know, so for an answer. And so I think that's a strong way that we've a strong example of the confidence and trust we've built.
Right. So when you know, once you get over the bootstrapping of trust, I guess, to some extent, as long as you keep doing it, you perpetuate it because you have enough important customers using it that you're like, see, they're using it, which is different than maybe like, you know, the type of topping you want on a pizza or the color you want your t-shirt to be, just some sort of fashion thing. It's more of just like it's demonstrated that it works for these other people, so you can kind of trust in their trust, so to speak.
Yeah, and then Docker Hub is where we've distributed the free versions of this content. They give us some metrics about consumption, and we've seen over like 1 million, you know, active servers pulling these images and charts from Bitnami. So that's kind of a more broad community data point too. Like 1 million active deployments on the internet says something too about even less demanding security environments, how they feel about the software.
So then so you I thought to have you on here because you this is actually back in October when I was rereading it, but you and our coworker Rita wrote up something about all of this with the kind of word salad of fun security stuff at the beginning. I'll explain in there. But you know, another thing that you brought up was having distroless images, right? And you were kind of walking through like, here's hardened images, here's distroless images. So what's a distroless image in this context?
Yeah, great question. Okay, because we're covering kind of the whole landscape now. So we talked about unhardened. That's kind of like your classic general purpose OS. Hardened is stripping it down just to what's needed for the app. And then Distroless takes that even farther, maybe too far for some taste, frankly. It's kind of going to this extreme of like an inhospitable environment for humans. Like imagine logging into a server and you don't even have a shell and you can't walk the file system and look at any files on the server. I mean, that's pretty ridiculous. But the advantage of this is a lot less packages to collect CVs, because, you know, lines of code are basically like magnets for CVs over time. It's just a surface area to attract. Kind of like, you know, if you have a really big table, just collects dust. You know, it's like the same thing. It's like more surface area collects more CVs. And then the other advantage is too, if a human does get into that environment, your number one concern if someone hacks into your software is privilege escalation. Usually, there's probably other concerns too, but usually it's to privilege escalate to get into something even worse. So imagine a human getting into an environment that has no tool. That's kind of like there's no oxygen for a human to survive. They're not going to get very far. So it's an extremely effective way to harden and secure your software. The downside is everything I just said. It's really hard to work with this stuff. Like, how do you debug this software? How do you troubleshoot it? It's kind of a pain in the butt. So
So I'm not a hacker, but I've seen a lot of TV shows. So tell me if this is semi-accurate, William. So in every show or movie I've seen, you see the hacker, they get onto some console, they magically guess someone's like username or password. You know, they look at a photo and they use someone's birth date or something. But the first thing they always do is they do like a DIR, and then they start going in. So what you're saying then is that if a hacker were to like compromise a system, like something like a file system or a file manager wouldn't even be accessible to them. So they wouldn't have the ability to kind of jump around and start doing things that aren't specific to the nature of whatever that thing is, whether it's a database or a messaging system or something like that.
Exactly. It probably really
Okay.
killed the plot in one of those TV shows when they stuck there like, oh shucks, now what do I
File
do?
not found. Yeah,
Yeah,
or command not found.
this is awkward.
Yeah. Okay. That's pretty
So
cool. I've never heard of that before, but that completely makes sense. That's pretty cool. But like you said, so I'm a big developer experience guy, right? And so I used to have a lot of developers that work for me. They would, if we had this, they also had some bad habits. So like they would write software that would access the files and stuff, local files and sometimes. So like what is the downside to this then? I imagine from a developer experience perspective, how does this change how they would work? I mean, do you do this in stages or do you kind of work bimodal where you have like, hey, we're going to do something in dev and then once it's in production, we do things differently? Like what's the balance there?
yeah, it requires more effort for sure. In the development environment, you can definitely have a different container that's a more full-featured version of the same Distroless container that you will eventually use. And then when you get to production, you can just rebuild into this Distroless version. So then you're not doing as much debugging there. Then if you do need to debug in that Distroless container that's maybe in production, you'd use a sidecar container. So we don't actually have to have all the tools in the container. What we do is we sideload a container, we attach it, kind of like dock it in the space station, like a little module docks onto the side, and then they can, move tools from that module into the container environment to do stuff and inspect the file system. And then once you're done, you detach it. So it's not that bad. I mean, by doing this, you're getting back to a usable environment to do your debugging, but it's an extra step.
So in that case, I mean, how does that work? Like are you building effectively like a new container that replicates the other one by layering in these new things, and then you execute stuff on it, and then you know how to build a new container? But how do you attach a sidecar to a container? Like, is it running or is it a different one? Like, how does that work?
I think what's happening is you're actually attaching another running container to the same file system. So they're both,
Right.
I think it's two processes. You got your first container, which is just essentially a proc in your Unix table, and then you got another proc that then
Right.
sees the same file system, so it can make IO commands against that same.
That makes sense. Okay. Yeah. That right. So you at some layer you may not have the same state. I don't know how all this stuff works, but like you're essentially it'll be, maybe you even do have the same state. I have no idea, but that makes sense. Huh. Okay.
Yeah, I think you're right. I don't think you have access to the memory. You're
There
not,
that yeah.
but you have access to network sockets, and you could. This is probably getting beyond my top of mind expertise, but I think some things you might do, for instance, is like if you have a MySQL server, you have a port usually that's internal on loopback, and on the sidecar container, you're going to start to talk to that MySQL through the loopback port, which you have access to because you're mounted to the same network and file system.
Yeah. That sounds cool. So like you're saying, you like bring the diagnostic tools that you want, but they're not there by default. And so when you create these distroless things, how, I mean, I guess this is part of the work that y'all would do. How do you determine what to strip away? Like, in theory, if you're running like, I don't know, Postgres or MySQL, I guess you have to like know everything it might do to make sure that's still on there.
Yeah, yeah. Well, so the distroless idea, Google is kind of the instigator of this idea, and they've open sourced a lot of patterns and technology. So a lot of what this looks like starts with the Google pattern. So when you get into like a MySQL, then there's this question of actually how are you going to orchestrate MySQL, and then that brings into the topic of Helm charts as well. And we could come back to that topic if there's time, because there's actually a distroless dimension of Helm charts as well. But essentially, there's a Google pattern for what a distroless image is, and you can think of it as doesn't have a shell, doesn't have a lot of user space tools.
William, I would imagine vendors or providers would be incentivized to release a distroless version of these things already. Are you starting to see that happen, or is it still up to third parties to kind of take what's available and then make distroless available?
Yeah, I haven't seen vendors do much in this yet. I think the market is still getting used to this idea. So if we think about who wants to use these types of images, it is more work than a lot of people are willing to put in. So it's probably the people who love this type of stuff is probably someone who might spend time in a skiff or maybe a bunker somewhere and working in a really high security environment. If you're doing that, if you're already going into a bunker every day, this is not the most inconvenient part of your day. I'm pretty sure, to use a Distroless image. You're already doing a lot of like sneaker net, air gap shenanigans that are not take some time and effort. So you're okay with this. If you're working at a fast-paced company and you gotta keep those door metrics flowing and get ship code fast, maybe this is a distraction still and hasn't risen to the level of necessity. So I think we're still early in seeing the middle of the market adopt this, but it's starting. We're starting to see some more security-minded companies do that, and so I think this is kind of a new frontier, which I'm excited to kind of nurture and help support because it's going to make security better for everybody.
And do you think if in the same way that there's that y'all have like hundreds of different hardened images, is it possible to create hundreds of distroless images that therefore make it, because you're sharing that work across the world or the customer base at least, does that mean it's easier for everyone to use it, or is a distroless image like unique per organization using it? Like, is it a generalizable thing that you can just use and someone just has to do the work eventually, or is it specific?
Yeah, it's definitely the former. It's very generalizable, maybe more generalizable because there's even less stuff. There's less decisions to make about what you put in the image. It's as vanilla of a choice as you can get almost. It's the only sort of hang up is that aspect of, okay, I gotta change my workflow. I gotta deal with a sidecar container, and I gotta change my
Right.
tooling. And I think the ecosystem could grow a little bit there to make those tools better. Someone should step into that, I think.
Yeah, I was just about to say. So again, like this is a space I'm not familiar with, but trying to make things easier for developers is, I would imagine like the ideal end state would be, developers have this developer environment where they're working with Distroless, but at the same time there is like some sort of set of development sidecars that are attached, and so their development process is probably a lot more easy than just working with Distroless. And then they probably detach sidecars, run testing, and if everything works, like you ship it, right? And then and then it's already working Distroless. Like these sidecars, I'm imagined, are not that mature yet, probably, right? So there's probably still a lot of sort of manual work to come up with those sidecars, or is that something that's also progressing?
I think I think it needs more attention. Like almost, I don't know, 8 or 9 years ago, I went to a talk here in Silicon Valley at Oracle. The Oracle Cloud team was working on. They had something called Crash Cart, and I think you can even see it's on GitHub, but it's been retired. You can search it, but it was a sidecar container framework, a bunch of pre-built ones with a bunch of user, super helpful tools that a developer would need, and just for this exact purpose. And then it kind of fizzled out. So I just think we're kind of not at that critical mass of adoption yet. For whatever reason, people have other priorities, and
Yep.
AI is a big focus right now. Maybe once
Yeah.
AI gets a little more mature, we'll have more time for this type of stuff. And I don't know.
Yeah, developers are rarely very enthusiastic about security stuff, adding work for them, unfortunately.
Understandably, I mean, got a lot of work already to do. So
Yeah, there's always that one person on the team who says you can't do something because of security reasons, but they're a developer, so you just ignore them instead of the the actual security people who have more power for it, unfortunately. But well, speaking, so you brought up Helm charts a few times. Like, how does a Helm chart fit into all of this? Because that's anyways. I won't answer the question. How's it fit into what hardened images and distro lists and just the notion of like securing the image that you're running?
yeah, so that's an even more new territory. I haven't seen a lot of other vendors or open source projects address that. Distroless has been primarily, so if you go to the GitHub page for Distroless, it's a container focused effort right now, but it really applies to virtual machines as well. You can make a virtual machine Distroless. And then it also applies to Helm charts. Excuse me. So what? So take, for example, MariaDB Helm chart. So when you install MariaDB in a container, there's a life cycle. At initialization, you're going to need a lot more binaries and utilities to set up that database for the first time than you will at the long tail of the life cycle or the lifetime of that database. After you've set it up, it's just going to be.
Oh, we lost William just as it was getting to the good part. You're muted, Kote.
Oh, I was saying it's quite the cliffhanger.
I know. I was like, this sounds so interesting. He'll be back in a minute. Yeah, I'm Googling this this Distroless thing.
So when you were running this, you would do all this. Your team would do this stuff on its own, like kind of approve the images and
yeah, like it was a
sort to
collective
them?
effort, but I mean, but that's a sizable effort. I mean, I can't. There's several teams involved. There's multiple organizations, leadership structures. There's a lot of coordination. And if you recall back to one of the conversations we had, like you know, eliminating all of that collaboration is like a really good thing. And so being able to outsource this or just subscribe to something like this is, I mean, that's awesome. I can't believe that's a thing. Maybe I'm just been too out of the game, but he's back. William's back.
Oh my gosh, so sorry.
No, we were just commenting, like we got right to the good part. It was like an awesome cliffhanger, and then you were mentioning like during an install process, there's all these things that like MariaDB or like a MySQL or something needs to actually do an installation, and then you cut off.
Oh wow, that was a plot device. Yeah, I was really trying to raise the suspense.
Yep.
Tune in next week to find out what happens to MySQL. Okay, so what we do basically is we segment out all of the binaries that are needed to run MySQL into multiple containers, and then we can run them in parallel in the Helm chart. The Helm chart can orchestrate this. And so then at startup, we're running all the Helm charts that are, the containers that are needed. And then as soon as the initialization Helm charts finish, we can discard those. And then we're only left with the tiniest running payload needed to run to maintain that database long term. And so then you're really doing kind of like minimal, the minimal required overhead to run that database. And we're getting rid of all the, the startup utilities or things like scripts and user creation tools and things that could have a lot of CVs in them. So you're getting rid of all that stuff that could be vulnerable.
Oh, okay. So you sort of divide up, like if you're running the database, you divide up all the different parts that it would want in a unhard install, so to speak, and then you spin those up into different containers, and once you actually get it running, kind of bootstrap it, to use that word again, you get it started up, then there's likely a whole bunch of other things you don't need, so you can remove that, and then that allows you to install and get running through a Helm chart your database. But then once it's running, you just delete all of that stuff or discard it. And then right, I'm just repeating exactly what you said so that I get it in my head. But yeah, that makes sense. And but normally, I mean, I guess normally people leave all that stuff behind, just sitting there running.
Yeah, I was just about to say, like you mentioned unhardened, but I would imagine, William, correct me if I'm wrong, like even today on something hardened, it still contains all of those things, right? Like this sounds like this is even a step beyond that, correct? Or
exactly. I mean, this is always a continuum, right? Like we go a little bit in the direction of hardening, but there's always more you can do, and that's what this is taking it even further, because it's more complex. Because now the Helm chart has to do have a lot of dynamic logic to change the definition of what's running at any moment in time. Typically, Helm charts are more simple, like declarative state. I'm just running this at all times. But now it's actually dynamic, where my definition of state needs to change as the application evolves.
Right. And then yeah, so you could even you could switch it around. So like we run this database in a read only mode in this hardened state, but then at some point we need to write to it. So then we're going to switch it around to making it a little less hard, as it were.
Yeah, that's exactly the type of thinking of which achieves these better security outcomes, and the results are pretty incredible. This change compare MariaDB. We built a prototype with MariaDB versus regular fat MariaDB. The difference is 83% smaller than other vendors' Helm charts, with 50% less packages. So not so bad of an outcome.
Wait, hold on. So when you say, what were the percentages again? You said 80?
Yeah, 83% smaller in terms of software amounts of bits on the disk, and then 50% less package count.
That is incredible. Like, how? Okay, how is this like not? I mean, I'm just saying from my perspective, like, I think if execs knew about this or like security experts, I mean, maybe they do, but like this hasn't come up in a lot of conversations. Like, I would think everyone would be wanting like more of that and investing in it. I guess to your point though, AI is kind of stealing all the oxygen out of the room, but that seems like a really, have you guys done any benchmarks with anything else, or has MariaDB been the main one that you guys have just done in the time being?
No, we've done some others too. I think we have 10 of them, if I'm not mistaken.
Okay. That's
Uh,
incredible. Like that's really, that's a lot. That's a lot. So like, so if I'm a hacker, and again, I'm not an expert here, but you're basically saying I have like, roughly speaking, 17% of the threat surface available to me, like with this sort of setup than I did previously when it comes to MariaDB.
yeah, for 99% of the life cycle.
That
Because
is
that first
absolutely
1% at
incredible.
the beginning, we needed
Yeah,
that stuff, but most of the time the hacker might try to get in is actually in the long tail where we can get rid of
right.
that.
Holy smokes. That's incredible.
When I talk to customers about that, they're very excited. Um, so I agree with you. Like this needs more attention. But I think what's happened too is just getting any hardened image period into an environment is still soup du jour of a lot of
Yeah,
IT teams.
I was about to say, I mean, there's levels to this. So we talked about this as well, right, Cote? Like when we were talking about like agentic AI app development, and I have a lot of companies that are like, hey, we want to start doing AI development. It's like, you should probably just get like continuous delivery going, right? I mean, there's levels to these things,
Yeah.
but I think this reinforces something that we've talked about a lot when you're thinking about platforms as a product and platforms as a whatever you want to label it. But the fact that like a lot of companies don't have a team of folks dedicated to like ensuring that these levels of maturity are like continuously happening within their company, like it does set them back. Like it's hard to latch on to this level of security when you're still trying to do things from like two levels of maturity before. And so I just think it reinforces the need to have that organization and that discipline within a company.
And so how does that fit in, William? Like let's say we've got a bunch of existing developers. We could just make up some app. We'll just call it the app. It doesn't really matter what it does. Like and someone like Tony was like, we need this. 99% of the time I can have 83% less attack surface, or whatever. Like how does this kind of thing fit into an existing like just developer process? Like, or I should say software lifecycle process. Where does it fit in? What do you integrate with it? Like how am I hooking it up to it? What's that look like?
Yeah, yeah. So I think there you could just follow the same pattern of in my development pre-prod environments, I'm going to use a fat Helm chart, classic one, and then but I'll have the equivalent if for production a Distroless version. So that's why our catalog it offers both MariaDB and both Distroless and the fat version. So you have something that's compatible, the same variables, and it's just kind of a flipping a switch as you get to that last stage of the SLDC. Um, then there's also the question of, yeah, you probably we're talking Helm charts here, so there's kind of a greater question of like, what's your development strategy with Helm? What's your container platform? That's probably bigger of a topic than this conversation, but you should consider that as well. And where these are also containers as well. These also have a container form factor, so you can run these on a local environment without Kubernetes. You can run these on other container platforms that are not Kubernetes. So there's broad. It depends on. It probably needs to look at what the development environment's choice of tools are as well.
But essentially, you'll have a registry or a catalog or some place that you would go, whether through like in the command line to get it, or I don't know, probably only there, where you would you get access to it. You download the container, whichever hardened one you want, and that would get you the container. And then I guess along the software delivery lifecycle, at some point, like in a Cloud Foundry way, the developers would like write all of their code, let's say their Java code, and they would compile a jar. And then at some point that gets handed off to whatever Tanzu platform or Cloud Foundry thing you have running. And that platform needs to get a container image from somewhere. And so that would how does that integrate into your stuff?
Yeah, so that would be that place it gets the container from would probably be an OCI registry. Our solution is designed to integrate with customers on-premise OCI registries. So you just configure our solution, our catalog, and we'll just be delivering automatically all the latest versions of those images and Helm charts to that registry. So then you just run that command Helm install from your registry, and you're just expecting that there's an up-to-date copy there that we've published or pushed into your cache.
Right.
But William, I think correct me if I'm wrong, but what about the parallelization of like executing those Helm charts, and like that seems like that's kind of a custom thing or a needed thing, or am I wrong? Like I'm imagining, like, can an OCI registry do that? You know what I mean? Like, or like how do you do sort of that orchestration of multiple Helm charts? Like, where does that happen?
For the Distroless outcome that we were
Yes.
talking?
Yeah.
Oh, that's actually one Helm chart with multiple container images.
Okay.
The Helm logic does all the orchestration. So it's one Helm install. And the user's just going to see a database startup at the end. That's kind of the outcome. We're going to be doing the magic and the logic of the Helm chart to flip the containers
Okay.
around and start and stop them.
Okay, so it's still the foundation is still just Helm charts, and it's all based on orchestration and APIs and stuff that are available within that ecosystem itself. So you don't have to have anything custom that's doing that orchestration and running.
Yeah, there's enough logic. I mean, I think it's borderline Turing complete, the Helm framework at this point. So you can actually do
That's
quite a lot of
awesome.
logic.
Okay.
I don't know if that's awesome, actually. That makes
Well, okay. As soon as I said it, I was like, okay, wait, hold on.
This is the problem with declarative syntax. And,
Yeah. Okay.
But it's nice in this case. And then, yeah, the only noticeable difference would be if I just started the thin Helm chart at the end, I might need a sidecar to debug it.
Right.
So it's a little harder there. But if I use the fat Helm chart, I can log in and do my normal stuff.
Yeah, it seems like the law of declarative programming is eventually it becomes imperative. There's just sort of like a clock you start running, and eventually you need that, or it creeps in, which is always thrilling. But at least it was a good run until then. Whenever that happened. I mean, you start off with HTML, then you have JavaScript, and then you've got YAML that has all sorts of execution parameters in it now. It just eventually it's imperative.
Cote's clock. Can we call it that? I like this principle.
Sure. That sounds good. It's at least right twice during the day, if I remember.
Cote's law. Yep.
So I think maybe as the last thing, unless there's things to come to mind we haven't covered at this level yet, is so how does this fit in with like the custom applications that people write? Like, does this, like I mentioned, you've got some Java developers and they hand off a jar, the application for them to run in kind of a Spring situation. Like, does what we're talking about get into that layer, or is that a whole other area when it comes to like hardening that kind of stuff and securing it?
Yeah, if we're talking about individual jars or libraries, there's a Spring based way of solving that. That's better to look at. And there's, especially if you're in the Spring ecosystem, there's a ton of collateral benefits for choosing that path. But how this would work with a Spring environment is middleware. So I'm creating my Java app and doing it in Spring, having all the fun, with that framework, and hopefully using a good platform to be able to build and deploy. And then let's say I need this is awkward. Bad timing. Maybe I should just go to text. I'll just type out my answer. I'm back. Okay. Imagine then you need something like a ClickHouse data, time series database, or you need a OpenSearch document store that you want to throw documents into from your custom app. That's where you would, if you're developing your app, as a developer, I just want to get my prototype working as fast as possible. I want to do the least amount of work getting OpenSearch or ClickHouse running. So what I'd love to have is something I can click a button and I get a sane single node best practices running installation of that, which by the way, if it's secure and meets my compliance officers and regulatory requirement standards, if it meets those needs as well, even better. And so that's where our catalog would come in. You would get a, let's say, a ClickHouse environment. You could push a button and have a ClickHouse running on your local environment or in your platform, and then start developing your code against it.
So to rephrase it back, so if I never know what word to use for this, but you use my favorite word. You need some middleware, right? Like you need some components that are for your application that you didn't write, databases, I don't know, frameworks, whatever. So you would get that can be a hardened chart or a hardened image that you provide, right? Or also just a base operating system that you would use. Like you could just say, I'm going to write an application and it needs to run on something, right? And at least I know that this base container that I have, this operating system, is fine. But then when you get to like the application layer, I mean, if you think through everything we've just said, it's not like your team can go and verify every single application and harden that image, right? So once you add your own custom software, it doesn't really do anything for that, except make sure that the image that you're running on the operating system is itself hardened and all the middleware components that you added in.
Yeah, that's a great point. So yeah, if you're layering on top of our containers, then there's a limit to how much we're able to guarantee about the outcome, and there's still some work for you to do. And that's where a platform, of course, is really helpful, because then there's a lot of tools to help you achieve that. But if you're also going to build your custom app and do whatever you need to do layering it, but then adjacent to that, you're going to need that middleware component, and that has to ship with your app. That would be nice to check the box there, so you don't have to mess with anything on that part. So like Apache Airflow is an example, common tool now used in a lot of data crunching applications. If you're gonna need that container running alongside your custom app, let's say you're successful with your prototype, you get it to production, now you're gonna ship it, and let's say your customer is a regulated customer, like a government or a bank. It'd be really nice if the image you started out with happens to also have all the compliance documentation to prove to that auditor it's secure. And so that's one less thing for you to deal with at the 9th hour when you're trying to now ship to production and get your software running, because you chose the right image to start with for at least your middleware part of your constituency.
Right, totally. I mean, I think that's something that Tony and I and other platform people talk a lot about. Is one of the things you want the platform to do is maximize everything, standardize everything below the actual code that's variable, right? So if the application developers are only paying attention to their own code and everything else is, for lack of a better phrase, static, like it's the same and unchanging, then you get all the benefits you were talking about. You trust that entire stack underneath the developer layer, which means you don't have to spend time on it over and over again each time there's a new release, which seems great. That's part of what the platform should provide.
Yeah, that's the dream.
The dream. Well, speaking of the dream, do you have anything else we should go over that we missed, William or Tony?
I don't have anything, but William, if there's anything that you can share where, myself, or if there's other folks listening that want to kind of keep abreast of these efforts and how things are going, like what's a really good place to check out if you have anything?
Yeah, bitnami.com is where, we try to land most of our announcements, and then also GitHub/bitnami. You'll see a lot of, activity and comments, and we try to use GitHub issues a lot, since all of our Debian-based images and our Helm charts are all open source, and we try to, leverage the community dynamic there. Yeah, I think that's a good place to stay in touch. And I am excited about 2026 and announcing more innovations. I think I'm also just excited about getting some of these technologies broader adoption. Like we talked about, there's still so much untapped potential with things like Distroless that haven't been widely adopted. And that gets me excited just about the good for all of like the industry and all of humanity ultimately that we can do to make things more secure by just raising the water, raising the watermark of baseline security in that area. That's an easy thing for us to all improve, and that could make a huge difference, especially as more connected devices on the internet and we become there's more and more bad actors sometimes on the internet that are testing the boundaries of security. So I think I think it's important in 2026 to invest in security and figure out ways that collectively as an industry we can improve. So I'm excited about that.
Yeah, well, we'll have to check in a little while and see how the optimism has been playing out. But no, it should be. I mean, just like Tony was saying. I mean, I think it's you gave us a good explanation of how this fits into just like being able to ship more software and making sure that it's secured and everything. That's great. Well, thanks again for being on. And Tony, I still haven't gotten a domain name for us or anything, so I have no CTA except we're in the VMware Tanzu YouTube channel. You can check it out there, and I'll update the links for this so that there'll be some below. And with that, we usually stream every Tuesday at 4 p.m. Amsterdam time. What time is it yours, Tony? I forget.
I'm on the spot. 10 or 11 a.m. I think it's 11 a.m. I think.
Yeah. But we scheduled a little later for our friends in California today. But next week we should be back at that time. And with that, we'll see everyone next time. Bye.